Day 261 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again doing another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 148, sort list. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. So let's get into it. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check that link out in the description. So let's get into it. Question says, given the head of a linked list, return the list after sorting it in ascending order. So, sounds easy enough, but let's look at example 1 just in case. So in example 1, we have the input head equals a linked list 4, 2, 1, and 3. The output is a linked list 1, 2, 3, and 4. All they did was take this original linked list and sort it in ascending order, meaning from smallest to greatest, right? So first we went 4, 2, 1, 3, which is kind of a random order. Then we go, the output is 1, 2, 3, 4, starting at 1, ending at 4, with 2 and 3 in the middle just to make it ascending order, right? Just to rank these nodes from smallest to greatest. So let's look at example 2 where they try to throw some negative integers in there, but it's still the same principles, right? So in example 2, we have the input head equals a linked list -1, 5, 3, 4, and 0. The output is -1, 0, 3, 4, and 5. Same thing, they just took this original linked list and they sorted it in order from smallest to greatest, smallest being -1 and the greatest being 5. So let's look at example 3 where they may try to throw some tricks our way, give us an empty list or something. And in example 3, they gave us head, which equals an empty linked list. The output is an empty linked list because we didn't have any nodes to sort. We didn't have to sort anything, so we could just return it as is, which is an empty linked list or blank array. So let's get into the fun part, the actual solution. So the first thing we need to do is we need to create a helper function, right? And this function is going to merge the two sorted linked lists into one sorted linked list for us, right? So in order to do that, we're going to come outside of this main function and we're going to say func, we'll call it merge unsorted list. Open up the parentheses and we're going to pass in some parameters. We're going to say underscore list 1 colon. That's going to be a list node. We're going to then say question mark, comma. Then we're going to say underscore list 2 colon. That's going to be a list node as well. A question mark. And then it's going to return, you guessed it, a list node. Boom, question mark. Now it's time we need to create some pointers to traverse both lists. So in order to do that, we're just going to declare a variable called list1. We're going to set that equal to list1, and we're going to declare another variable called list2. We're going to set that equal to list2. So this first pointer is going to traverse the first list, and then the second pointer is going to traverse the second list for us. Now we need to create a dummy node to simplify the merging process. So in order to do that, we're going to say let merged list colon list node question mark. We're going to set that equal to a list node, open up the parentheses, and we're going to say -1, -1 in there. Boom. Then we are going to say, or we need to create a pointer to build the merge list as well. So we're going to declare a variable called current, and we're going to set that equal to merged list. Boom, just like that. Now we need to compare and merge nodes from both lists until one list is empty. So in order to do that, we're going to say while list1 exclamation point, that should be exclamation point equals nil, which this exclamation point means while list1 does not equal nil, and then we're going to say and list2 exclamation point equals nil. So while list 1 does not equal nil and list 2 does not equal nil, what we are going to do is we are going to see first we need to see if the value in list 1 is smaller, and if so, we need to append it. So in order to do that, we're just going to say if list 1 exclamation point dot val is less than list 2 exclamation point dot val, we're going to open up the brackets, and we are going to say current question mark dot val, excuse me, not dot val, dot next equals list 1. Boom. Then we're going to say list 1 equals list 1 question mark dot next, just like that. So if the value in list 1 is smaller, we're going to append it. Otherwise, we need to append the value from list 2. So we're going to say, we're going to come right here and we're going to say else, open up the brackets. We're going to say current question mark dot next equals list 2. Come underneath that, we're going to say list 2 equals list 2 question mark dot next, just like that. Now we need to move the pointer forward in the merge list. So in order to do that, we're just going to come underneath this else, and we're going to say current equals current question mark dot next. Boom. Now it's time to append the remaining nodes from the non-empty list, from the non-empty list if there are any. So to do that, we're going to come down here outside of the while loop. We're going to say current question mark dot next equals, open up the parentheses, list 1 exclamation point equals nil. Then we're going to come outside of that. We're going to say question mark list 1 colon list 2. So what this is going to do, remember this right here is going to return a Boolean. So if list 1 does not equal nil, if that's true, then we're going to return list 1. If it's false, we're going to return list 2. That's what this question mark right here is doing. Then it's time to return the merge list starting from the first real node and skipping the dummy node that we created. So in order to do that, we're just going to say return merged list question mark dot next, because we need to skip the dummy node. Boom. That's it for the helper function, but we're not done yet. It's time to get into the main function. So let's get into it, right? So with this function is going to sort the linked list using the merge sort algorithm that we just created with the helper function. So the first thing we need to do is we need to create a base case to see if the list is empty or has only one node, right? Because then that means it's already sorted. So that's going to handle like a case, for example, 3 if the list is empty, or if the list only has one node. So in order to do that, we're going to say if head equals nil, or, so this right here is going to handle the case if it's like example 3 and the list is empty. Then we're going to say or head question mark dot next equals nil. Boom. That's going to handle the case where if it only has one node. Then we could just say return head. Boom. Just like that. Now we need to initialize pointers to help us find the middle of the list. So in order to do that, the first pointer we're going to initialize, we're going to declare a variable called slow. We're going to say colon, it's going to be a list node, question mark, and we're going to set that equal to head. Now the slow pointer is going to traverse the list one node at a time. Now we need to create another pointer called fast, so we're going to say var, call this fast, colon, that's going to be a list node as well, question mark, set that equal to head. And then the fast pointer is going to traverse the list 2 nodes at a time. Boom. Now we're going to declare another variable called prev, colon, that's going to be a list node as well, question mark, set that equal to head. And the prev pointer is going to keep track of the node before the midpoint for us. Now it's time to use the slow and fast pointers to find the midpoint of the list. So in order to do that, we're going to come down here and we're going to say while fast question mark dot next does not equal nil, so exclamation point equals nil. We're going to open up the brackets. We're going to say prev equals slow, and that's going to update the prev to the current position of slow. Then we're going to say slow equals slow question mark dot next, and that's going to move the slow pointer one step forward. Boom. Then we're going to say fast equals fast question mark dot next question mark dot next. And what that is going to do is it's going to move the fast pointer 2 steps forward. Boom. So now we need to split the list into 2 halves by disconnecting the first half from the second. So in order to do that, we're going to come outside of this while loop. We're going to say prev question mark dot next equals nil. Boom. Now we can recursively sort the first half and the second half of the list. So in order to do that, we're going to say let first half, boom, equal sort list, open up the parentheses, head. Boom. Then we're going to come down here and we're going to say let second half equal sort list, open up the parentheses, slow. Boom. So this first half is going to sort the first half. The second half is going to sort the second half. Boom. Now we need to merge the 2 sorted halves into a single sorted list. So in order to do that, we could just say return, and we're going to call our helper function from down here. We're going to say return merge unsorted list. Open up the parentheses. We're going to say first half, comma, second half. Now, that should be all she wrote, y'all. Let's run it, see how it runs. Drum roll, and it's accepted, y'all. So let's submit it. Make sure it stays accepted, because we all know how LeetCode can get. Just because it's accepted don't mean it's going to run when we submit it. But guess what? This one did, and it's 308 milliseconds and beats 28.79% of users with Swift, y'all. Not too bad, not too bad at all. As y'all know, we're going to get those numbers up as we continue down our LeetCode journey. But right now, we're just focused on being able to solve a problem that's been presented to us. And I feel like this is a good solution for that. It's easy to understand for all levels, and we will be able to use this knowledge that we've learned from this solution and further in future solutions, y'all. So get one more look at the code before we go. Boom. This is the first main function right here. Get one more look at the main function. That's the main function. Boom. Now get one more look at the helper function. One more look at it. One more look at it. And yeah, man, read it, learn it, love it, internalize it. I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.